Hello everyone, welcome to the review for Unit 4. So we're going to have 1 day of review and then we're going to be taking our test starting tomorrow. So the first part of this exam is going to cover solving equations and systems using graphs. So we've been talking about how to take an equation and solve it using a graph. So we're going to go over that again today. I'm going to demonstrate this today using Desmos and MyOpenMath. So we're going to actually go open some problems in MyOpenMath. We're going to open up Desmos. I'm going to show you how to use Desmo to solve some of those problems. Last week when I initially presented the lessons for Unit 4, I showed you how to do it on the TI-84 graphing calculator. So if you're more interested in using those and you're comfortable with the TI-84, you can go back and watch the videos from last week to kind of get a review on how to do that. But for the review today, I'm going to go with Desmos because I know some students like to use Desmos, and that's fine. All right, so I'm going to show how to do those problems just on the screen here in just a couple minutes. And then we're going to come back to our notes here, and we're going to do the day 2 stuff, which is going to cover rational expressions. All right, and you need to be ready to add, subtract, multiply, divide rational expressions, and then find the excluded values. So in today's review, I'm going to show you a division problem. I'm going to show you an addition problem. The other operations, you'll need to go back to chapter 3 and watch some of the older videos if you feel like you need to review the other operations. All right, so let's go ahead and get started. We're gonna start on the day 1 part, which is where we're gonna solve by graphing. Okay, so I'm gonna pull up a problem here, and this one you might recognize this one from last week on the quiz. So our goal is to solve this equation up here. We have the square root of 4 plus 2x. And we're setting that equal to negative 4 plus 4/3 x, right? And we want to solve this equation, right? We would normally draw a line and we would start moving things around from left to right until we got x by itself, and we would state a solution for x. Right? It's a lot easier to do an equation like this, especially one this complex, on a graph by finding the point of intersection. Right? So the way that we do this is we take the left-hand side of the equation. So we take this square root of 4 plus 2x and we graph it. And then we take the right-hand side of the equation and we graph that, and then we look for where they are equal. And on a graph, we say that they are equal when they intersect each other. All right, so we're looking for a point of intersection to reveal the solution. Okay, so I'm going to do that on Desmos over here. So I've got Desmos opened up. If you're not familiar with Desmos, you can go to Chrome, open up a Chrome tab, and type in desmos.com. Right, and you just hit enter, and you'll end up at a page that looks like this. You just want to click on the blue button that says Graphing Calculator. Right, and it'll take you to this screen. You'll see your graphing screen, and then over here you'll see the blank fields where you can enter in your equations. All right, so what we're going to do is we're going to take the left-hand side of the equation here, the square root of 4 plus 2x, and we're going to put it into field 1 over here. So to get your square root symbol, you have to come down here to where it says keyboard. Open up your keyboard. You'll see a lot of stuff kind of pop up. You get all kinds of symbols and stuff that become very handy. We're looking for the square root symbol, and we're going to type in 4 plus 2x. All right, and as you type in your function, you'll notice that Desmos automatically graphs it over here on the grid for you. All right, so this is the left-hand side of our equation. Now I'm going to go to field 2, and I'm going to put in the right-hand side of the equation over here. All right, so I'm going to type it in exactly as I see it. So we got a negative 4 plus, and then we got 4/3. So I just do 4 divided by 3. That automatically inputs a fraction for me, and then I'm going to get out of the fraction by hitting the right key and then typing x. And you'll notice that when I do that, you'll see the line pop up here immediately on the graph. All right, so you see red function, you see blue function. Now I'm going to make the keyboard go away, and I'm also going to make the fields go away, so that way I can just focus on the graph here. So I get a nice big picture of the graph, and if you can zoom in and out using your touchpad, so you can zoom out, you can zoom in, and get a closer look at things and see where things are at. You also have a zoom in and zoom out feature over here on the right, which is kind of nice. The other thing that's really cool about Desmos is that if you click anywhere, it'll give you a point, right? So you can click on these points and get instant points that you need. Now, we know we're interested in the point of intersection, so we're looking for where blue and red cross each other, and that's right here, and it pops up the point for us at 6, 4. So that's our point of intersection here. So I'm going to come over here and I'm just going to type it in 6, 4, making sure I state it as an ordered pair, right? So it's complete with parentheses x, y. Right? Now the solution to our equation, when we solve this thing, if we were solving this by hand, we would solve it for x, right? So we need an x value that makes this equation be true. Well, in our point of intersection, we know that these two things are equal at the point of intersection, but in the point of intersection, we have x comma y. So the x value is 6. Right, so that is the x value that's going to make this true. If I were to plug in a 6 on both sides of this equation, we would actually get a 4 on both sides. It would end up saying 4 equals 4, which is a true statement. And that's ultimately what we want, is a value of x that makes the equation be true. Okay? So we actually got this first part done just by finding that intersection point. But now we actually need a graph. MyOpenMath wants to make sure that you can graph these two equations and find that intersection point as well. All right, so we're going to just make sure that we read our instructions up here. I kind of laid out for you step by step. So it says here in step 2, use the line tool to draw the horizontal line. All right, so y equals, and it gives you the function. So down here when they talk about the line tool, you see line, you see square root, and you see the point tool. We want the line tool, so I'm going to select that, and we're going to draw this line. So to do that, we need 2 points. Right? So I can come over here to Desmos and I can get 2 points. I can get this one right here at the y-intercept. So I can start my line at 0, -4. So I'm going to come over here to MyOpenMath and I'm going to click on the y-intercept at 0, -4. And then you'll notice it wants me to place a second point. Right? So that way it gives my line direction. I can come over here and say, okay, well, I can get a second point at 6, 4. So I'm going to go right 6, 1, 2, 3, 4. And place the second point just by clicking. You only have to click once, and now my line is set. The line is graphed. All right, now it says in part 3, use the square root tool to draw the left-hand side of the equation, right? That's the square root part. So we've got that graphed over here on Desmos, and it says to draw this function, first plot the point furthest to the left. All right, so on my graph over here, the point furthest to the left is right here. So when I click on that point, you'll see we get -2, 0. So I'm going to switch over to the square root tool. I'm going to go to -2, 0, and I'm going to click. And then as I move my mouse around, you'll notice that it wants a second point. So you can get a second point from anywhere. Right? So we have another point right here. This is the y-intercept for the square root function, so 0, 2. So I'm going to click on 0, 2, and then it sets my square root function. Okay, so now I've got the square root function graphed. I've got the line graphed. And so we're going to go to step 4. It says use the point tool to identify the point of intersection. So this is the point tool down here. So I'm going to click on that, and I'm going to go to my point of intersection, and I'm just going to place a point on the point of intersection. That identifies the point of intersection. All right, and then state our solutions, which we already did, and that would make this problem complete. All right, so you have graphed, you identified the point of intersection, and you used the point of intersection to find the solution. So if you hit enter, right, it should give you all green check marks, which is good. And that completes the problem. All right, so let's try another one. We're going to go to this one, right? Same type of problem, right? We got an equation that we need to solve. We're going to solve it by graphing. So I'm going to go to Desmos. I'm going to clear out my fields 1 and my field 2. And we have a new left-hand side, a new right-hand side of the equation. So I'm going to put in the left-hand side of my equation first. So I'll pull up my keyboard here. We need x squared, so I'm going to type x, and then you'll see your square button is right here. And then we need plus 2x plus 3. And you'll notice over here, you see the parabola being graphed for us automatically. We'll look at the graph in just a minute, right? I'm going to go back here to MyOpenMath. I want to get the right-hand side of my equation, so I need this -x plus 3. So -x plus 3, just type it in. And you'll see the line pop up on the graph, and that's it. We're ready to go. We're ready to start analyzing the graph. So I'm going to use the arrow just to hide those expressions so that I can just look at my graph and see what I'm dealing with here. Zoom in and out, explore the graph a little bit. And you know that what we're looking for are the points of intersection. Okay, so we have a point of intersection right here. That's at -3, 6. So I'm going to come over here and type that in. And we have another point of intersection over here at 0, 3. So I'm going to type that one in. And it does say if there is more than one intersection or solution, to separate our answers with a comma. So I'm going to go in between my two intersection points. I'm going to put a comma there and make sure that I follow those instructions carefully. Okay, so there's my 2 points of intersections. Now, these solutions, remember the solutions are the x values from those intersection points. Okay, so we've got an x value of -3 in the first one. And then we've got an x value of 0 in the second one. So my two solutions to this equation are -3 and 0. All right, so those are my two solutions. All right, now I got to get this thing graphed, right? So it says use the line tool to draw a line. No problem. So I'm going to select a line, and I'm going to get 2 points that are on the line. And I can actually use the two intersection points here. So I can say, well, one point is at 0, 3. So I'll click. And another point's at -3, 6. So I'll go left 3, then 1, 2, 3, 4, 5, 6. Place that second point. There's my line. All right, now I'm going to use the parabola tool to get the parabola. All right, that's the green function here. And we need, it says to draw this function, first plot the vertex. So I'm going to come over here. The vertex is located here at -1, 2. So I'm going to go -1, up 2, and I'm going to click. And you'll notice that as I move around, it wants me to place a second point. So I'm going to place my second point over here at 0, 3. So there we are, 0, 3, click. All right, and that sets my parabola. All right, so the parabola and the line are graphed. And it says in part 4, use the point tool to identify the points of intersection if it exists. All right, so we do have 2 points of intersection. So I'm going to select the point tool, and I'm going to click once, click twice, and now I have identified my points of intersection on the graph. Okay, so there we go. That completes the problem. And so if you click submit, and it should grade them for you. It should give you nice green check marks as long as you followed the instructions carefully. Okay. All right, so let's do one more. And this one was from the quiz last week. So again, this one is a system, right? We want to solve the system. And remember, all a system is a collection of 2 or more equations. And so we have 2 equations going on here, and we're going to graph both of these, and we're going to look for the intersection point. So it's a lot like solving an equation. The only difference is we have to state the x and y values, and we're going to do that by stating the ordered pairs of the intersection points. All right, so I'm going to go back to Desmos. I'm going to clear these out, and I'm going to solve this the same way. I'm going to put in my first line, and you can put a y equals in there. It doesn't make a difference if you do or don't. But we're going to do 9 divided by 4. X, right, because that's my first equation here, plus 8, right? And for right now, don't worry about the graph. The graph will automatically do its thing. And then we have y equals 5 over 4 x plus 4. Okay, and we're going to come over here and we're going to take a look at our graph. All right, so here's our graph. Zoom out a little bit, get a good look at it. Right? And I'm looking for the solution. Remember, the solution is going to be located at the intersection point. So I'm going to come over here. I'm going to click on this point where the intersection is. And so we can see the intersection is at -4, -1. So all you have to do is just type in, right, -4, comma, -1 as an ordered pair. Because remember, when you solve the system, you have to state x and y. Right? And we're doing that just by stating the intersection point. There's our x value, there's our y value. So what that's telling me is if I took that -4 and I plugged it in for x into both of these equations, I'd get -1 out for both of them, which makes them equal to each other. Okay, so now we just got to get these lines graphed. So the line tool is down here. It should be automatically selected because there's only lines in this equation. All right, and just like the previous ones, we need to get 2 points that are on each line. Okay, so there's going to be 2 lines that we got to graph. So I'm going to start with the black line. So we have a point at 0, 8. So I'm going to click on 0, 8. And then we need to get a second point. And let's see if we can get a nice point somewhere like maybe here. So we got -8, -10. Right, so you see how I just kind of click. This looks like a nice point. And all right, so we're looking at -8, -10. We should get some nice integer points. So we're going to go left 8 and then down 10. So right there. And I'll click. And that sets the black line that we have in our Desmos graph. Now I'm going to go get the red line, right, which is the other function. So I'm going to click here. I like to get the y-intercept. So we got a y-intercept at 0, 4. So I'm going to go click on 0, 4. And then I'm going to try and get a second point somewhere. Let's say this looks like a nice point. So -8, -6. All right, so I'm going to go -8 and then down 6. 1, 2, 3, 4, 5, 6. And I'm going to click. And that sets my 2 lines. And you can see our intersection point. We don't actually have to mark the intersection point on this one. It doesn't say that I have to put a point on the intersection, but we can see it right here at -4, -1, which was where we said our solution existed. All right, and then when I click submit, it should tell us that we got everything right, as long as we plotted those lines correctly. All right, guys, so that is using graphs to solve systems and equations, and that is using the Desmos graph. So if you like Desmos more, by all means, use it when you get to the test. If you like the graphing calculator more, use the graphing calculator. All right, and here we go. So we're going to move on to the part for day 2, and we're going to talk about simplifying rational expressions here. All right, so we've got a rational expression. We've got x plus 4 over x squared plus 6x plus 8, and notice that the operation here is division. All right, so division means that we have to do a little KFC. So if you remember, this stands for keep, flip, change. So we keep the first fraction, right? So I'm going to write x plus 4 over x squared plus 6x plus 8. We're going to flip the second fraction. So I'm going to take this second fraction, I'm going to flip it. So the x plus 2 is going to go on the top. The x minus 2 is going to go on the bottom. And then the C stands for change. We're going to change the operation to multiplication. Okay. So before I try and actually multiply these things, I'm going to take my expressions here. I'm going to make sure that these are all factored. So these are all binomials already, so that's good news, right? So I can put these all in parentheses like this. And just recall when we cancel things out in these rational expressions, an x plus 2 will only cancel out with another x plus 2. And x plus 4 is only going to cancel out with another x plus 4 in the bottom. All right, so, but this thing right here, this is not factored yet. So we need to do a little bit of factoring. I'm going to take this x squared plus 6x plus 8, and I'm going to use my box and diamond to factor it and see what I get. There we go. So we put the x squared in the upper left-hand corner. The 8 goes in the bottom right. The 6x goes in the bottom of our diamond, and then we multiply our diagonal to get the top. So we've got 8x squared. All right, so I'm looking for two numbers that multiply to give me 8, but add to give me a 6. So that is going to be 4x and 2x, right? 4 times 2 is 8. 4 plus 2 is 6. So those are our two numbers. Okay, and then we work the outside dimensions, right? X times x gives me x squared. X times 2 gives me 2x. And x times 4 gives me 4x. And now we can see our factors. Okay, so this x squared plus 6x plus 8, let me change my eraser here. I'm going to replace this x squared plus 6x plus 8 with my two new factors. So we're going to have x plus 4 times x plus 2. Right, now, since we are multiplying, I always like to think of multiplying as the one that bridges the gap here, right? So it's just like when we multiply straight across the top and straight across the bottom. So really we're just kind of joining these two fractions. So in the top we're going to have x plus 4 times x plus 2 over x plus 4 times x plus 2 times x minus 2. It's like they all just kind of join into one big fraction when we multiply it across the top and the bottom. Now, a lot of you guys are trying to multiply these out. You don't have to do that, all right? You're making it too hard on yourselves. Just put them together in one big fraction, keep it in factored form, and look for the common factors that cancel out. All right, so notice that we have an x plus 4 in the top and an x plus 4 in the bottom, so the x plus 4s, they simply cancel. Right? Also, notice that I have an x plus 2 and an x plus 2, so the x plus 2's will cancel. So the only thing left is this x minus 2, but we have to make sure that we write it in the correct way. So when we cancel things out in fractions, these are actually big giant ones, right? X plus 4 over x plus 4 becomes 1. X plus 2 over x plus 2 becomes 1. So really this is 1 times 1, which is 1, that's what's in the top, and in the bottom you have 1 times x minus 2, which is just x minus 2. So this becomes my simplified fraction, and then we need to state our excluded values. Okay, so what values of x are we not allowed to use? That is dependent upon the factors that are in the bottom. Right? We don't want any value of x that allows us to divide by 0. All right, so if I look at each individual factor and I look at this one, I say, well, what value of x would create a 0 inside of this factor? Well, that would be -4 because -4 plus 4 makes a 0. So I'm going to exclude -4. Then I look at the second factor here, x plus 2. Right, so -2 plus 2 would make a 0. So I need to exclude -2. And then over here in our last factor that was in the bottom, x minus 2, well, that would be a +2 because 2 minus 2 makes a 0. So I need to exclude +2. So this becomes my final answer. The simplified version of this fraction after division is 1 over x minus 2, as long as we exclude -4, -2, and +2. Okay. So that is division. Let's take a look at some addition. All right, so notice again, the operation in between the two fractions here is division. They forgot to put parentheses around this x minus 2, but that's okay. We'll fix that for them. And then we're going to add these together. Now remember, when you add or subtract, we have to get a common denominator. All right, so whenever you add or subtract fractions, you have to have the bottoms of your fractions be the same. So currently, when I look at this fraction, this one has an x minus 15 and an x minus 2. This one only has an x minus 2, so they're not the same. But I can fix that by multiplying by whatever it's missing, right? So if this one has an x minus 15, well, I can multiply by x minus 15 in the top and in the bottom. It's a nifty little trick that works because really all we're doing is multiplying by 1, right? And when you multiply something by 1, it doesn't change its value. Okay, so after I do this, what we're going to get is 15 over x minus 15 times x minus 2 plus, now in the top, right, we get 8 times x minus 15. Just leave it alone, right? You're multiplying it just by putting it together. You don't actually have to distribute yet. Okay, we are going to distribute on this one and get rid of those parentheses, but first I want to get the addition part down and done before I do any kind of simplifying. All right, so once I multiplied there, now look at my two fractions. The denominators are the same, so I can combine these through addition. So when we add two fractions that have the same denominator, we put them together with that common denominator, right? So we're going to keep the bottom. So we've got x minus 2 and x minus 15, and then we add the top. So we're going to get 15 plus 8 parentheses x minus 15. Now technically at this stage you have added the fractions together, but we can simplify the top a little bit. All right, and I know this is what you guys were itching to do here, is to distribute this 8 into the parentheses and see what we get. So we're going to get 15 plus 8x minus, let me grab my calculator here because I'm lazy and I don't feel like doing that in my head. So we got 8 times -15, and I got -120, so we got minus 120 all over x minus 2 and x minus 15. Okay, and then the last thing I'm going to do is I'm going to combine like terms, right? I can combine the 15 and the -120. Oops, again, I'm using my calculator because I'm lazy, which is -105. Right, so we could say 8x minus 105 all over x minus 2 and x minus 15. Right? Don't forget about your excluded values. So we're going to exclude a couple of values here because I'm looking in the bottom. A +2 would make this one be 0, so we're going to exclude +2, right? 2 minus 2 makes 0. And then in this one, 15 minus 15 will make a 0, so I'm going to exclude 15 as well. All right, so this becomes my final simplified fraction, and these are my excluded values. All right, guys, that's it for today's review. I hope you found those problems helpful, and I hope you all do well on your exam tomorrow. Good luck.